good. Lab 1 is due today. If you want to make any corrections, if you want it turned in Lab 1, you have to turn it in by tonight. Okay, so Lab 1's deadline tonight. Then when you come back on Thursday is Lab 2. So what do you need to have for Lab 2?
3 lab.
You need to have the 3 lab done. If you come and it's not done, you'll have to work on it. You'll have to finish it while we go into the lab. Okay, so that'll waste your time. Make sure, also, make sure you're working through Alex chapter 2. Some of us are done with that, so good job if you're done. If you're not done, make sure that today is the last day of notes. So we'll have covered everything on chapter 2 Alex. So make sure you get that done, okay? Questions about our schedule. So we're here, Lab 1 due. We'll do Lab 2 next time. We'll do a review day. Then next week we'll have chapter 2 tests. Okay, no questions?
Oh, wait, isn't it a half day on Wednesday? Next Wednesday?
Yes. It's 10 questions.
Oh, okay.
And we'll still have 50 minutes. So we can work something out if you need more time.
Oh, I hope not.
Okay. I don't think you'll need more time, but if you need more time.
I hope I understand. I think I'll get it. I took it
Notes. Okay, here we go. We're going to talk about electron configuration. So first, if I have germanium 74, how many electrons?
74.
So it's not 74. How do you figure out how many electrons? Germanium.
Oh, yeah.
Okay, what number is germanium on the periodic table? Find it?
32.
It's 32. What kind of element is it?
It is a German element.
Metalloid.
It's a metalloid. Okay. 32. What does 32 tell us?
It's got 32 protons.
Good. 32 is the number of protons. So if I have 32 protons, this is neutral. How many electrons? Also 32. Good. 32 electrons. Okay, good. How many neutrons would this have? Just for fun?
So whenever, I don't know, 40. So whatever.
42? Oops. Okay, we agree with that? All right, good. So we need to know where our electrons are. Where are they?
What are electrons?
Just where?
Negatively charged.
Oh, there's the rings around.
stuff.
Yeah, good. They're in the orbitals. Good.
Oh, what are the electrons?
So electrons are, or orbitals are the predicted space that we should expect to find an electron. We have S, P, D, and F orbitals.
And then isn't there only like 2 electrons in F, like 4, and then like
Yep,
6?
we'll talk about
that.
Yep.
I hate those.
Oh, okay. So we're going to start off with what you need to know. I would probably write this on my note card. Okay, so this is the order of the electrons. So notice we have a big letter 1, and then S, and then we have, this is called superscript 2. The superscript is important, or like squared, the S is squared. 1S squared 2, 2S squared 2, 2P squared 6. This is something you either have to memorize or write on your note card. And the rest of our notes today, we're going to talk about what this means. So as you figure out what it means, it makes more sense. And you might not even have to memorize it. You might just, you can figure it out with the periodic table.
Does it ever go this far?
We will stop at argon for the test. The test stops at argon.
What does it stop at on those things?
So it would keep going to like the last elements.
Is there not a 1P?
There is not a 1P. Good observation. There is only a 1S. And we'll talk about what this means.
Maybe even
What's the first 3 levels?
That is so long.
Don't like nutrition.
I was
So
actually
hard.
like, I was actually like,
I'm failing fixing my test score. Oh, 52. Whatever. I'm at like what, 74? 78. 76.
that's not bad.
That's a D.
That's
How are you
not bad,
doing?
like, like this for last time.
It should still be a C.
What's that?
Then also a sign. I mean, I scored pretty low on that. Oh, wow. So, like one was worth like 5 years or something, and I got like 3 years.
All right, are we ready? Okay, so this is our. All right, this is our orbitals. We have s orbitals. They're spherical. Are you ready? Okay. Sorry. Okay, so we have s orbitals, p orbitals, d orbitals, and f orbitals. Okay, so that's what this SPDF. That's what we're talking about. Okay, so the shape of the orbital. This also tells us how many we have. So if we have an s orbital, there's only one shape. If we have a p orbital, we have 3 different shapes. D orbitals have 5 different shapes. F orbitals have 7 different shapes. So it goes, do you guys see a pattern? 1, 3, 5, 7. Oh, so you don't have to remember this. This is just to help you understand what that sentence we just wrote down. Okay. So this is P has 3 orbitals. So you don't have to write this down. You won't.
I just want to like.
Okay. Okay, but I might not let you write the whole thing. Okay. The other thing you need to know is we can fit 2 electrons in each shape. So I can fit 2 in an s orbital. I can fit 2 in each of these. So how many does that make? 6. 2, 4, 6. How about this one? How many electrons can I fit in a d orbital? 10. How about an f orbital? Good, 14. Because we can fit 2 in each of these shapes. Okay? Okay, we got that. So spherical orbitals, oops. P is like a dumbbell shell shape, or like a peanut, they said. D orbitals, they are divided in the 3D plane, and then the DC has like these 2 lobes above. Do you guys remember talking about Schrodinger in your chemistry class? Or his cat, yeah. This is what Schrodinger's equations predict the electron geometry to look like. So this is Schrodinger's model. When we talk about the electron cloud model, this is what we're talking about.
It's all his fault.
It's all his fault. This predicts bonding really well because of where the electrons are. If we imagine like, oh, there's electrons here. Oh, it's bonding to this other thing. We know that that's true because of the shape of the electrons. Okay, f orbitals. All right, so when we use that sentence, what we're doing is we're following these rules. First, we always. Are you talking about orbitals?
Yeah.
Oh, you are? Okay, perfect. Okay. So we fill the lowest energy first. We always fill the lowest energy, and then we fill the orbitals, okay? If we have orbitals that are on the same energy level, then we're going to put 1 in each orbital and then go back and pair them. Electrons don't like to share their orbital if they can help it. So if it's the same equal energy, then they're going to fill each orbital at the same energy level and then go back and pair. Okay? And then when we do shove them in the same orbital, remember up to 2 can fit in an orbital, we have to do something called spin flip. We have to have 1 electron with an up spin and 1 with a down spin.
Yeah, so it's like those arrow thingies.
Yeah. Yep.
How do I simplify this second one?
Fill electrons in equal energy first, then pair. So these rules is why we have that sentence. Okay, that sentence 1s2, 2s2, 2p6. That's from these rules. So if you just remember that sentence, you don't really need the rules. Does that make sense? Okay. All right, so here's a diagram. This is an electron filling diagram. So we start with the lowest energy level. Electrons are lazy, they fill the lowest energy. How many can we fit in this orbital?
1.
We can fit 2. And then this bubble.
6.
2 here, it's an s orbital 2. And then we can fit 1, 2, 3, 4, 5, 6. Okay. Then we can fit 2. Okay, and we just start filling. We can just fill this.
Can I just write it down and stuff on the other side? Or is not for
We
that?
don't. Do you want it?
Yeah, can I just touch on
2, 4, 6. See, 2, 4, 6.
Okay.
So
There's
on,
some more
you
helpful
go-
charts.
Go back to the slide so I can tell. C2P, the orange, it has 3 above it. It would be 2, 4, then 6. Then it would be 6. See what I'm saying? So then the 3P would be, what would it be? 3, 6, would be 9, right? Or am I wrong?
So if it's, are you talking about this one? This one
No,
can fit.
the one above it. 3P and then, yeah, that.
So you can fit 2, 2, 2.
Do you know what the
Yeah,
highest
2, 4, 6.
communicating
2, 4,
level
6.
is
6.
Yep.
Yeah.
Why is it 6? What is it 3? Like,
Let's do some examples. We'll get there. So this is another chart we could use, and you fill the 1s, then you fill the 2s, then you fill the 2p. I don't like this chart, but if that's helpful to you, I don't like that one. I like these boxes. Okay, we're going to use the boxes to do some examples. The other thing I like is that the periodic table tells us where the electron should be filling. Okay, so this is where we're filling s orbitals. So it's called the S block. This is the P block because we're filling the P orbitals. The valence electrons are in the P orbital. This is where the D orbitals are filling. So it's called the D block. And the bottom is the F block because that's where the F orbitals are. Okay. And these notes our notes are always on Canvas too if you miss something.
So cute.
Okay, so let's go ahead and do an example. You got it? Okay, so how many electrons does hydrogen have? Okay, 1. How do we know that?
because of last chart.
Because hydrogen has 1, that's 1 proton, 1 electron, okay? So we're gonna start down here. We're gonna put an electron down here. So this is telling me the spin. Let's keep track of that. So this, then we account for where the electrons are. We just are saying where they are. So 1s, 1. We have 1 electron in the 1s orbital. That's the electron configuration for hydrogen. Neutral hydrogen.
Do you need to put the 1
Yes,
up there?
yes. So a lot of the time in a chemical formula, you don't put the 1 if there's a 1.
Yeah.
This you have to.
Okay.
Good question. So this is telling me I have 1 electron in the 1s orbital. We're good? Okay, let's do the next one. Helium. Where will my electrons go? How many? Well, let's start with, we got 2, good. Where will they go?
In the 1s.
Good, they're going to go in the 1s. We have to spin flip one of them so that it'll fit. Okay, so this is 1s. We have 2 electrons in that orbital. Okay, we're doing okay? Can we fit any more in the 1s orbital? No? So what about lithium? What are we going to do? Oh, we'll skip that.
So it'll be 1s, 2s, 1.
1s, 2, 2s, 1. Good.
All?
So we have how many electrons for lithium? We've got 3.
So confused.
Okay.
We put 2 in the first orbital.
So like lithium is number 3 on the periodic table. It has 3 electrons, and then you like put 2
2
electrons
here.
in the first orbital.
We have 1 left.
And the remaining
3.
1.
Oh, okay.
Oh,
That makes more
yeah,
sense.
yeah.
That makes more sense.
So we've got 2 in the 1s,
Yeah, so we took
1 in the 2s.
2s, like.
You're good?
Then it goes up 2, and if it had 4, it's below 2s,
Oh, okay,
and
got
then if
it,
it like
got
had 1,
Okay, that makes more sense.
yeah.
Okay,
Got it.
let's try beryllium. How many electrons does this have? 4.
So 1s2, 2s2.
Good. So we're gonna put them 1s2, 2s2, and that's the electron configuration.
Okay.
That's
Okay, let's do boron. We have 5 electrons. Good.
so how 12's going to
Good.
1s2 because it's just one orbital.
Wait,
Okay, wait.
Around.
Well, wait.
okay, no.
You got it? Okay. So now we're gonna go to carbon. Right now we have 1 in the p orbital. Carbon's gonna have 1 more. Where do we put it? Yep, in the 2p. When we draw our diagram, it's gonna go in its own orbital. Electrons. See how these are on the same energy level?
Yeah. Oh!
So we're gonna.
The second
It's gonna
box.
go in the second box.
That's
Good.
weird.
So carbon will be like this: 2, 4, 6.
But it would still be 2 and 2.
Yep, good.
But we don't
Still
have to
2.
draw them, right?
We don't have to draw that.
Oh, now I'm a little
I'm
more
good.
confused.
Okay.
How would we get to 2p again? I forget about that. So,
So we start with carbon has 6 electrons.
yes.
So we've got 2 here, 2 here. We've got 2 left. They're gonna go in the p orbital.
Oh, okay.
So then
And we've
so
got
then-
2 in the p orbital.
Okay, so then let's say we have, would it go up to 3s?
Not
No.
because
No.
so how many we get? Okay, 2, 4, 6, 8. 8 would
Oh,
stop.
okay, so then,
So it would be like 1 more in the third box, and then the other one would go down. In
Oh.
the first box. No, it's
Okay.
weird.
yeah.
Nitrogen. What would nitrogen be? We got
1s2, 2s2, 2p.
good. Yep. Okay.
So
Wait.
P can fit like 2 electrons. One of them.
The p orbital can fit 6. Is that what you're asking?
6.
The p orbital can fit up to 6 because remember our p orbital has 3 shapes. 1, 2, 3. 3 shapes. Because we have the X, Y.
Hey, you doing good? Okay, so
I don't get how
nitrogen
nitrogen
has
like
7.
all 14
See how
of the
nitrogen
electrons.
has 7? See, 1s has 2 over it, like the
Has 2 of the
2.
Oh,
Two,
oh,
three.
no, okay. I was just looking at the atomic mass.
Nah.
I know that never happened.
Okay.
Never happened.
Okay.
Last 5 minutes never
Good
happened.
to
Last 5
understand
minutes
what's
never
going
happened.
on. Okay, how about oxygen? Try oxygen.
1s2,
Yes.
2s2, 2p4.
Okay.
Okay.
So now we have to pair one. You see that? We filled up the p orbital. We gotta go back to the first p orbital. Okay.
So
So how many electrons does oxygen have?
8.
Okay. And if we add these superscripts, so 2 plus 2 plus 4, we should have 8. That's one way to check. Make sure your superscripts add up to the right number of electrons. Okay, great.
Yes.
Okay, if we jump over to neon, neon has a full shell. Okay, so if we look at the energy level 2, our energy level 2 is full. Okay, and if we look over on the periodic table, everything in this column is a noble gas. They are noble gases because they have this full shell. They're really non-reactive. They don't want to do anything because they have a full shell of electrons. Okay, so we can predict based on this orbital diagram. Yep, Sebastian.
So how
and
would
then
the
Bill.
full shell actually work? I'm kind of just a little confused on
Okay, so this is energy level 2.
it. Okay.
Can you put any more electrons?
I don't think so, no? Or, yes?
So where would you put them if you could put them?
More than 2s? Or,
Okay, so then that's energy level 3.
okay,
So this number in the front is telling us the energy level.
okay,
So energy level 2 is full. We
okay,
can't put any more electrons in there.
okay,
So that's a full shell.
okay, got it.
Okay.
Alright, that makes sense.
And then Phil, you also had a question?
I'm just wondering, can noble gases like still share electrons between other elements?
If you make them.
Oh, okay.
So I know there's a compound with xenon like hexafluoride.
I got it. You finally get it?
So, rarely.
Rarely.
Rarely, yeah.
That took me so long.
Or I know argon can become a plus charge
That took me so long.
if you put it in a plasma. So it's like under extreme conditions.
But you go like, oh, yeah, I get it.
All right, we're doing okay? Okay, that was our last example.
He has got it.
So on the test, you will be responsible for knowing up through argon. Okay? So how many electrons does argon have?
18.
Good. So you would just use your sentence and figure out how many electrons to put where.
So that would be like, so argon would be like 1s2, 2s2, 2p6, 3s2, and 3p6. And that would be a whole
Yep.
argon.
Yep.
Okay. Testing the balance now. That's not horrible then.
Where is my?
So then
I'm trying
that's
to
like
click my.
Lawrencium. Does that like have a 5s and like 4d and like 8?
Uh-huh. Yeah.
That's like really big.
Yeah. Yep. Yes. Okay, go ahead and try 20. Try calcium. See if you can do calcium. Figure out the.
Oh wait, I like them in boxes.
Oh, do you want boxes?
Yeah, that helped a lot.
Okay.
Calcium.
I like those boxes.
So
Oh,
the
1, 2, 2s, 2,
2s,
6.
Wait, 2p6, 3s.
Calcium. Calcium 20.
That's 4s. Write it down.
It just
No,
goes, it goes on like
I
4.
literally got it right. It's I know. I said 1s2,
Calcium.
2s2,
You're trying to do calcium.
3s2, 3p6, 4s. Wait, no. What did those 3
I
be?
should have done that one right.
No. She said 3p6. Yep. And then it would go 4s.
No, I'm just
Oh,
telling
you're
you.
counting. Okay, that's fair. That's fair.
Did you have any better
I think it goes.
Oh,
whoa.
whoa.
So,
Like, give me like the chill. I don't like thinking about that.
1s2, 2s2.
Well, have you ever tried like poking well and get surprised? Yeah.
Like,
Yeah, surprise, Alan.
1s2, 2s2, 3p6, 3s2, 3p6. What did the 3s2?
Wow, this
Wait,
is
so it
so
goes
soft.
1s2,
I know,
2s2, 2p6.
Okay, I'm going to show you how you can check these.
All of it's
Supposed to be
So if we go to,
Yeah, but I had to school bus.
4s2.
if we go to the P table,
So
and we go along the top,
Can you think about it?
if we go to electrons, it has a nice little box for us. And we can click on, maybe I want to look at nitrogen and I can fill in the electrons. It also tells you what's the outermost orbital, and I can be like, oh, well, what about this orbital? What does that look like? How about this one?
4s2.
Okay, and that's kind of fun.
That's so
So you're saying Lawrencium way down here,
Yeah.
it's filling an f orbital. We can look at what the f orbitals look like.
Whoa.
1s2.
So let's go ahead and we'll look at calcium. This is the electron configuration for calcium.
4s2.
So it has the expanded, this is what Alex is going to ask you for. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Phil?
So it's in the block of the final one. Since calcium has like S at the end, it's in the S block.
Yes, yep, since these have S at the end, they'll be in the S block. These have D at the end, these have F, P. Good.
1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay.
Wow, good eyes.
Yeah,
The other thing, sometimes we write this as a noble gas abbreviation. So we just go to the nearest noble gas and we say, oh, well, we know that we have argon, and then you just add everything past that noble gas. So this is the noble gas abbreviation for calcium is argon, and then 4s2 electrons.
Oh.
I don't think Alex asked you for that, but
What else for what?
noble gas configuration. That's easier because then you don't have to write so much.
The configuration of
Oh, then this is
would be argon, which is 18. See argon or whatever it is on there. Then it would be already 18. So then you just do 4s and then 2.
Yeah, that's what I
Imagine
did.
if those and you have to put it in the
I just
line.
added.
Alex isn't gonna ask you that, but chemists sometimes use that.
So argon which is already 18 electrons, right? So that you would have.
Okay, we got that in there.
2.
All right, now we need to talk about these two different types of electrons.
It's just up to that point. It's up to this point. Right?
We have valence electrons and we have shielding electrons.
Oh, we never went over those.
So the outermost electrons are called valence electrons. So that outermost energy level we talked about, we were looking at the 2s and 2p orbitals.
Yeah.
Everything on the inside is called a shielding electron. Those are just the inner electrons. And we'll look at some of these. Did you have a question?
Wait, what did you say?
Configuration of calcium.
So it's only 1s2 that are shielding electrons, or
So anything on the inner energy level is shielding. Everything on the outermost energy level is a valence electron. We'll look at some examples.
Configuration. So since this is orbital.
Yep. Oh.
Another one. So we like kids who are like whatever you two electrons. That means they're like compared together, right?
You compared all the. You compared them. Okay.
What about like, I have these from like, like these are valence electrons or something, and then these are like energy levels?
Yep.
I just don't remember.
Yep.
These mean.
Yep. So this is energy level 1. It's spelling energy level 1. This is energy level 2.
You would think the outer electrons would be called shielding because these are like
Yep.
energy outside, but then
Shielding
these are like
electrons?
valence electrons.
Broken
Oh, and then I have like ions.
Oh, yes.
It's too weird.
So ions. This column is plus 1 plus 2 plus 3 plus minus 0.
I remember valence.
Yeah.
How do you find out how many valence electrons a molecule has?
We will talk about that.
Okay.
So you look at the energy level, the outermost energy level, the highest energy level, and you count up the electrons.
Okay.
Or you can remember what columns have. We'll talk about that. We care about how many valence electrons because that's what does the bonding, what participates in bonding. So everything wants to have a full shell, like our known gases. So our atoms fight until they have 8 valence electrons. And that tells us what is going to bond.
I have like 2 there. Yeah, I don't get it. Like I literally had to line up the nutrition thing. Cause like, she would have probably judged me if she was like, copy for lunch break. Just because so limited. I might work at Starbucks, just in our house. That is so cute. You don't like those stuff? No. I think that was stuff. Yeah, I get yelled at by old men, and I hate it. Okay. There's so many butter plant. I'm like, I'm trying to push you. Well, that sounds about my house. I should do that. They're not hiring us separated. So go to like March. No, I hate the small coffee, so I wasn't going to make Starbucks. I love the small coffee. I think I would like spend it
Or
for
just go to
days.
Centrico.
That's not by my house. I'm not going to start.
Write it down in one.
I live kind of far away. Yeah, so you would say.
Oh.
All right, are we ready? Okay, we're ready. So how many valence electrons are in oxygen? 4. Oh, so 4 in the 2p. Remember, we have to look at everything in the outermost energy level.
6.
So it's 6. We have energy level 2. It has 6 valence electrons. So look at all of the orbitals in the S and P orbitals. Yes.
So you would want like 2 electrons from other atoms?
Yes.
Okay.
Oxygen wants 2 more electrons. So we are looking at the outermost valence the outermost energy. 2 plus 4, that is 6. So oxygen has 6 valence electrons.
What?
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 That's crazy.
Oh, we just talked about this. This is the second time we talked about it.
Oh, alright. We're good.
Okay,
Don't worry.
so we just look at, this is energy level 2. We will count up how many electrons are in each of the outermost energy levels.
Oh, wait. Never mind.
No.
Sorry?
There's only 8 levels. And it's either 1S,
Well, like,
1S2, 2S2, and then
So who came up with this?
So you can just
I don't know.
into that one. So
Okay,
the last
so
one you can
who
just
came
kind of
up with the
alter
word
to whatever you
Yes. Yep, it doesn't have to be full. Right, you're right.
Huh?
Okay, this is another way to remember how many valence electrons each atom has. You can just memorize this order, okay? We're gonna ignore these, kind of do something different, transition metals. First column has 1 valence electron. Second column has 2 valence electrons. Then we jump over to boron's column. Everything in boron's column has 3 valence electrons. Then nitrogen, carbon's has 4. Nitrogen's column has 5 valence electrons. Oxygen's column has 6, then 7. Then the noble gases have 8, except for helium. How many valence electrons does helium have?
2.
2, because it can only have 2 electrons. They're all on the outside.
Wait, for which ones?
Helium has only 2 valence electrons.
Helium got only 2 valence electrons.
But wait, but did we just say oxygen was 8 on the previous slide?
Uh,
Or what was that not
oops,
oxygen?
wrong.
That was 6. Oh yeah, okay. Okay.
So does that agree? So either way, we'll get oxygen
added
at
the
6.
Okay.
Okay.
Wait, so that whole row's gonna have 6?
Everything in column
Do you want to write
6.
marker?
Oxygen.
Can I write that on this?
Try one of these. I don't know.
You guys want to do that? I'll bring some.
Okay, questions on that. So this is something, it's pretty easy to just count over. If you remember 1, 2, 3, 4, 5, 6, 7, 8. Or you could write that on your note card. We will need this going forward.
I got it.
Are we learning anything else for our
We are practicing,
Okay,
I think.
and then that's it?
I think so. Okay, this is kind of different, but it's like the same stuff.
Oh.
So based on the number of electrons in your electron configuration, you should be able to figure out what the atom is. Okay. So if this is a neutral atom, what's its identity?
Helium.
So how many electrons does helium have?
3.
Helium has 2.
Lithium.
Lithium. Okay.
You were
You were
close.
so confident. I was confused.
What are
Sorry.
valence electrons? Just the numbers, like
Electrons. So we have valence electrons. We look at the outermost ring,
Magnesium.
the outermost energy
Magnesium.
level.
So
It's fine, it's fine.
So this would have 1 valence electron.
How did it? And it counts 1, 2, 3, 4.
And we decided this would be lithium.
Yeah. And the one like below it's magnesium.
Okay, you think this one's magnesium? Do we agree with that?
And then
Yeah.
Oh, my pen is not working. Okay,
We need to get you into class.
I should just order one. So how many valence electrons for magnesium? Good. Outermost energy level is 3. There's only 1 orbital in the 3 energy level. We have 2 valence electrons for magnesium. We're doing okay? Okay,
So how do all of them in the same column have the same valence electrons? Or is that
that's how the periodic, so that predicts our properties of our elements. And then they ordered the periodic table based on the properties, and that matched up with the valence electrons.
so
I'm just trying to make everybody else smarter.
Okay.
What's this 1 plus 8?
This is the ion, so it has a +1 charge.
Sulfur?
So you think it's you think it's potassium?
Yeah.
Okay, explain to us. You think it's potassium?
Okay, so you add it all together and you get 18.
Okay.
But since
All of
it's
what together?
all of the
It's right next to sodium.
Okay, all of the
or not
superscripts?
Yeah. Just,
All the electrons, so we've got 2 plus 2 plus 2 plus 6 plus 6.
yeah.
And that gives you 18
Yeah.
electrons.
Yeah.
Okay.
So then, since it's an ion, you
Okay.
have to do the weird thing where it's like you can't get rid of the number of protons, so you have to get rid of a negative ion.
Okay.
So that means if you got rid of the negative, like an ion, then you have to add 1 more to that number, so it's going to be 19 protons.
Okay.
Oh,
Good, so-
I meant the lower one was sulfur.
Okay.
Yep.
So you're saying Eliza said that we have 18 electrons. If we have a plus charge, we can't change protons for the charge. We have to change electrons for the charge. So now we have 19 protons. Oops.
Why? Why is it chlorine?
19 protons. So now 19 protons, we can look at that's potassium. Good. Thanks.
I got that one right.
Yeah.
So why is it not sulfur? Because
Do you remember that thing where it was like when you have to do the proton thing? So if you're determining like whether it's a positive or negative ion, you can't change the number of protons. So you have to change the number of electrons. So if it's positive, then you have to
Does that make sense?
yeah.
Okay.
So you have to have more positives, so you have to have less
so-
electrons. So in order to have more positives, you have to use more.
Are you doing it, Cameron? Okay.
18.
But
So now I'm.
it's +1 for protons.
So, for each one, it's not on the same energy. Yes, they have 4.
Hey.
That determines what
Wait, no, I'm talking about number 2.
Oh, number
Jump down.
Why is it not sulfur? Oh.
Tell us what the next one is, Liz.
Oh, shit, so how many?
Okay,
Okay.
thank you. Like, no, it's chlorine. I'm like, oh my God. I think it's sulfur.
Walk us through why the last one is sulfur, Liz.
I am.
Yeah. Tell us.
But I just
2 minus.
walk through it. Walk through it.
Yeah, walk
So
through
it says 2 minus ions.
Okay. 2 minus ions.
Subtract 2 from 18 and you get 16.
So why did you start with 18?
Because I added 2 to 6, 2 it's 6.
Okay, so you're adding the number of electrons up again.
Yup.
So you're saying that is 18 electrons.
Yeah.
And then, why are you subtracting 2?
I don't know, it just says to do it.
Oh, it says 2?
No,
Oh,
it says 2 minus.
okay.
So I just subtracted. I don't know.
So you just subtracted? So how many protons does this have?
6.
16, good. 16 electrons, or protons, excuse me. Okay, so this is sulfur 2 minus ion.
Oh, thank you.
I
Okay.
understand that.
Okay, let's see. Let's look at this one. This one's a trick question. How many valence electrons does gallium have?
3.
1.
What? 3?
Oh, it is 3, good. So watch out, this is hidden.
That is tricky. That's so
This
hidden.
has 3.
So good.
Silly.
Yeah. Okay, let's check one more. How many does the sulfur 2 minus ion have? How many valence electrons?
8. I don't know.
Yep. Outermost energy level, 3 and 3. This has 8 valence electrons. Good. All right. How are we doing on this? Did that one okay? Okay. Something to watch out for. Alex is going to make you write ions. When you write ions, so if I have some ion and it's a 2 plus charge, I need to write the number. Did we talk about this already? Okay, I need to write the number first and then the charge. Okay.
-2 is wrong.
If it's just plus 1. If it's 1, you don't have to write the number. Okay, so watch out for that. Alex cares about chemistry grammar.
Yeah,
Okay, and that's all.
weird.
We have like 30 minutes left. I would make sure, if you haven't turned it in your lab, please turn it in your lab. And then, maybe do your pre-lab, then do Alex.
Yeah. This is show my mind.
Okay, so you're this one, just not outside. This one doesn't have. So
That's not
So my skills. What are you?
It's so it's
Yep, today, then it'll go right in there.
don't worry, I have to get it. I have to get
Wait.
I was over your lab.
It's like a big dad car.
Wait,
Don't worry, I